Welcome to Algebra 2, Lesson 2-7, Linear Quadratic System. In this lesson, you'll be able to solve linear quadratic systems. If you look at Explore and Reason, we can draw a rough sketch of a parabola and a line on the coordinate plane. So, for example, if you have the x and y-intercept, you can draw a rough quadratic formula for the parent function x squared. Count the number of points of intersection between the two graphs. Parabola and a line. So I can draw y equals x line as well. Just a generic parent function for each one. Count the number of points of intersection. We'll have 0, 0, and somewhere over here, right? Yeah, probably 2, 2. No, 1, 1. Yeah, so this is 1, that should be 1, because 1 square should also be 1, so that's another point that they would overlap. So you would have 2 intersection points. Sketch another parabola on a coordinate plane. Use a straight edge to investigate the different ways that a line and a parabola intersect. What conjectures can you make? So you can have a parabola and a line that goes through exactly one point. You could draw another parabola with a line that does not go through and does not intersect at all, right? Yeah. So then, what can we say about the possible solutions or intersections? We can see that a parabola might intersect a line at no points, at 2 points, or at 1 point. Where the line is tangent. It means like it's right on the parabola. Okay, so there are 3 different types of solutions for parabola and a line as well, just like quadratics, right? The zeros of quadratics. So it's the same kind of idea. How many different numbers of intersection points are possible between a quadratic function and a linear function? So like we said, like we explored, we would either have 2 different solutions, because if you intersect at 2 points, then you would have 2 different solutions, right? Or 1 if it's exactly tangent, and none if they never intersect, right? So depending on the intersection points, we will have different types and different numbers of solutions. So the linear function and a quadratic function can intersect at 0, 1, or 2 points. And by inspecting various graphs showing a line and a parabola, you can see that they might not intersect at all. Or they might intersect at 1 point, or they might intersect at 2 points. So let's think about the essential question for this lesson. How can you solve a system of 2 equations or inequalities in which one is linear and one is quadratic? So we'll look at our algebra part of this, okay? Let's look at example 1. Determine the number of solutions. How many solutions can there be for a linear quadratic system? just like we explored, we will have 2, 1, or no solution, or no real points. But we'll talk about complex solutions later, okay? Because whenever we don't have real solutions, that implies we may have complex solutions. So first of all, that's why they are specifically asking for real solutions here. So let's look at this example. How many solutions does the system x squared and 2x have? If you graph them, you'll see that there are going to be 2 intersections. So this system has 2 real solutions. What about these two? X squared and 2x plus b. So for whatever values for b, are we going to have different numbers of solutions? Yeah, we can test the values. If your y-intercept is -1, then you'll have a tangent line to x squared. So it's going to be exactly 1 solution. If it's something less than that, it'll never intersect the graph, so there is no real solution. And if it's greater than -1, then you'll have 2 intersecting points. So you'll have 2 real solutions, right? So just looking at it visually, it's really easy to see that you will either have 2, 1, or no real solutions. So let's look at try number 1. Determine the number of real solutions of the system y equals 3x squared and 3x minus 2. You can either graph with technology or by hand, but pause the video and see if you can figure out the number of solutions by yourself and come back when you're ready for answers. Okay, are you ready? Yeah, so how many solutions would they have? Why? If you graph them, you will see no intersecting points, right? When x is 0, y is 0 here, but so let's graph your sum of your points. When x is 0, y is 0 for 3x squared. When x is 1, y is 3. And when it's -1, it's 3 as well. And then your linear graph starts with y-intercept of -2, and then it goes up 3 over 1. And then it goes up 3 over 1. But your quadratic looks steeper. So check when x is 1. When x is 1, for your quadratic is 3, right? When x is 1, for your linear graph, it's going to be +1. So this is, this is 1, 1. And this point is 1, 3. And then it will keep getting further and further like that. Okay, so no, they're not going to overlap at all. It looks like they're going to almost touch if you graph it by hand, but if you graph it accurately, they're not going to touch. And always check by algebra. So no real solutions. All right, let's continue with the next example in the next video.